Okay, now we're going to try and prove this identity. So basically, to prove that an identity is true, no number of individual cases is going to work. So there's no point in us filling in various values for A and B and verifying they're true. They would be true, but that's not enough. So we must use deductive logic. So the whole idea is to show that either that the left-hand side, take the left-hand side and work with it and show that it's equal to the right-hand side, or vice versa. They're the only options that we have. So basically what I would like to do is use the right hand side because of the fact that we can use the compound, the sign of a difference identity, and I think it will come out quite easily from there. So we will begin with the right hand side. So the right hand side had read the sine of A minus B over cosine A cosine B. Okay, so heading in now with the identity for sine, a minus here is a minus here. A sine should have a pattern of sine, cosine, cosine, sine. And the arguments get populated in the same order that they appear here. Okay, now moving in along to the denominator, we have this. So the denominator can distribute. So let me be a bit cheeky here and say that cancels with that to give us the tan of A. And furthermore, then that cancels with that to give us minus the tan of B. Okay. Next, we have this identity here, and we must plan. And I think it's a kind of a no-brainer. We're going to start with the left-hand side and move to the right-hand side, unlike what we did here. Because again, we're going to be able to use the, and of course I've made one terrible mistake. If you like, I have not just tried to make this my own. So let's just roll back here and say, well, why would we just finish the task and not look back and try and appreciate what's just happened? So the sine, now I think by all means this is a weird or a difficult one to come to terms with. So the sine of a difference is equal to the difference of tans times the product of coses. The sine of a difference is equal to a difference of tans times the product of cosines. Okay, and you try to get a feel for that, see, oh yeah, I have that, that's now in my toolbox. Now, it's just a challenge, could you possibly repeat that? Could you produce that formula? So the sine of a difference is equal to the difference of tans multiplied by the product of coses. Okay, great. Moving on to the next calculation, we're going to begin with the sine of A plus B over the sine of A minus B, and we'll see where that takes us. Where we hope to end up, with the tan of A plus the tan of B. And it is important to know where you're going, because it will guide you in making decisions along the way. Okay, we say in maths it will inform your methodology. Okay, so that's where we're heading. We're starting here. So let's kick off with the identities. So sines will be a plus over a minus. We're going to go sine, cosine, cosine, sine, sine, cosine, cosine, sine. Okay, AB, AB, AB. And like I said to you before, you don't want to be in analytical mode when you're regurgitating and quickly getting work down. You're just writing as quickly as you would when you're rattling off an English essay. So now we get information from here because we know we want this to look like tan. So you could take any one of them to figure out what you're going to do next. You're going to divide across by something. But what am I going to divide across by? I'm going to divide across by, I got to get rid of cos b, so there'll be a cos b at the bottom, and I want a cos a. So you're going to divide top and bottom. Cos of b has to disappear, and a cos of a has to appear at the bottom. So you're going to divide by cos cos, essentially. Okay, so now that's going to be a terrible, huge thing to write out. So just don't bother writing it out. You can kind of work on the fly and say, well, the cos of b's will be gone, and you're done and dusted there by the time you say you're going to certainly be confirming that everything lands in like this. I mean, if you want to, just for your own satisfaction, but it's going to certainly be messy. Cos, cos. Not messy, just long. Protracted. Minus cos sine, cos a sine b over cos a cos b. Now all you have to do is you reuse this line because you've got a cancellation here is tan. You have a cancellation tan of a. You don't like this now very much. Cos sine cos cos. Yeah, you have a cancellation here, so you have tan of b. Good. You have a cancellation here, so you have tan of a. And you have a cancellation here, so you have minus tan of b. So that's verified. Now we're moving into the next with a whole new instruction. Write next block of questions. Write each of the following as a single sine, a single cosine, or a single tan. Well, that should be quite easy. So we'll just write this here. We'll use the sheet that it's on. So looking at this, I have a plus and sine cos cos sine. So this is screaming sine of a sum at us. Okay, so we're talking about the sine of the sum. But the sum of 2a and a is 3a. Okay. So sine something cos of double, sine of something cos of double plus cos of something sine of double is the same as sine of treble. Going to 15, cos cos sine sine. So cos cos is telling us it's a cos of a compound angle, and the minus here telling us it's the cos of plus. You switch this sign. Here you didn't do anything because it was a sine. Here you switch. So it's a cos of plus 5. So the cos of 5 theta is the answer here. Down here we go. So it's, hopefully you can make this out. Sines at the end, sine, cos, cos, sine. This is a sine. It's a sine of a subtraction. It's the sine of theta. Okay, so sine double cos minus cos double sine is sine of theta. Finally, we're moving in to, now this is a little bit, this is the extra one we did. It is one of the formula we have to know how to use, but it's not, we don't have to derive it, because this is the tan of a minus b, identity being used. So essentially this takes the form of a tan of a difference. So this is exactly the tan of 3a minus a. This is the tan of 2a. Okay, that's that.